Hello friends, welcome to follow up. Let's have a look at problem 2265, count nodes equal to average of subtree. In this video, we're going to explain a solution based on recursion. And also we want to treat how to update the result dynamically. So here, first let's look at the problem statement. So we are given the root of a binary tree. We want to return the number of nodes where the value of the node is equal to the average of the values in its subtree. So notice that its subtree will also count the node itself. So here is a note. Say the average of n element is the sum of the n element divided by n and rounded down to the nearest integer. So this is very important, right? So the second one is that a subtree of root is a tree consisting of root and all of its descendants. In other words, including the node itself. So here we have two examples. So in the first one, so this is a single node tree. So we just return the count of root itself because it's just one value and the average and its own value are equal. So in the first example, so we actually have 5 nodes. So first, each leaf node is a valid node, right? Because it just has one node and the average is for sure equals its own value. So in this example, we also have node 4 and node 5. So for node 4, so they can compute, and then the average is 4. So here, this 6 is a factor of 24. Well, for the node 5, so the sum of the 5 plus 6 is 11. And 11 divided by 2 is actually 5.5, but rounded to the nearest integer down, so it's going to have 5. So 5 equals 5. So we also count this node. So in total, we have 5. So with that said, let's also look at the constraints. So the number of nodes in the tree is in the range 1 and 1000. This is a closed interval. But 1000 is not a very large number, right? And secondly, the node value is non-negative and bounded above by 1000. So with that said, we are ready to look at the analysis. First, I want to mention, so here we are working with binary tree. In other words, it's a special tree data structure. So the tree data structure can be defined recursively. So in this problem, we are going to think of recursion. Certainly, there are some iterative formats you can use to solve this problem, right? So this is the one point. Another point is that for this problem, we are going to focus on 2 points. The first one is that for each node, we need to retrieve 2 pieces of information in order to check if it's a valid one. So these 2 pieces of information are the sum and the number of nodes for the tree rooted at a given node. So this is what we want to retrieve. And the second point is that in the same time, in order to achieve the first point, we need to do some traversal. That's not avoidable. So we want to do the counting in the process of traversal. In other words, we want to increment the count of the number of valid nodes in the process of traversal. So this is the second point. So as we mentioned, for the first point, we can achieve the goal using recursion very efficiently. And for the second point, so we can use attribute or field, or we can use non-local variable. So in this video, we are going to demonstrate both the 2 options for point 2. So with that said, I guess it's rather straightforward to do the coding, because the problem logic is also very simple. For each tree, you're going to check the sum of the nodes and then compare with this value by doing average, right? So with that said, let's first I'm going to do it using attribute. So let's introduce an attribute, self result. So this is the counting variable, right? So this attribute. for counting. And next, we are going to write a hyperfunction to do point 1. In other words, given a node, I want to retrieve 2 pieces of information, and the sum and the nodes, the number of nodes for the tree rooted at that node. So let's do it like this. Just use a function f. So first, I want to write a base case because this is the essential for recursion. So if not node, so in this case, I'm going to return 0, 0. The sum is 0, and the number of nodes is also 0. And then we are going to look at the left child and the right child, or more precisely, the left subtree and the right subtree. So the left subtree sum and the left subtree number of nodes, it can be retrieved like this: f node left. So notice that if we write like this, it's good. The reason is that we have already checked the base case, that is a null tree. Then similarly, we can retrieve the right part information. So right number of nodes, this f node right. Then we are going to have the sum and the number of nodes. It's going to be left part sum plus right part sum plus the node value. And then the number of node will be the left set node number of nodes, n nodes, plus right set n nodes, then plus 1. This 1 is counting the node itself. Then we need to update this variable. So basically we want to check if we want to do s integer division by n. So this will round it down, right? So then if this equals the node value, then we are going to increment this result attribute by 1. So afterwards, we need to not forget to return. So we want to return s and n, right? So this is our function. So when we do this problem, so we just need to call this function, right? Let's directly call this function. So you can understand this function as a worker to update this attribute, right? So here, this function have returns, but I just don't want to use it. You can write something like this, or you can just call this function. And then what we want to do after we call this function, we just return self result, right? So now with that done, let's first do a test. Name node is not defined. Do you mean mode? So that's where is the f node. Let's see here, node left. So here I guess so we need to call this for the root, right? So now let's do the test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So let's regard this one as version v1. So now let me copy this part of code. And then I'm going to change this one as version v1. And then I want to change this. I want to use a non-local variable, right? So this is the variable for counting. And then here, when I write this function, I can declare non-local this result. So I use this outside this function, right? So then what I want to do is I just adjust this part. And then adjust this part. So this gives a format of using non-local variable. So now let's look at the test case. Yeah, it passes all the cases. So with that done, that's basically about it for this specific problem. I would say for this problem, the quick summary is that when we look at problems involving binary trees or some other general trees, you can think of recursion because of the data structure nature. Secondly, in this problem, a point to notice is that how to increment the counting when we do the traversal.